Hello everyone. So after discussing what is meant by the observation and what is meant by understanding, then we also discussed what is the significance of the basic scientific principles or laws or concepts in the case of any system or while building any system. So we came to know that every system must be understood as a combination of different laws, principles and concepts. If we neglect something, that may lead to the failure of the system or product. Same thing can be applicable to the events or incidents. So further to this discussion, so we are going to know, after understanding the scientific principles or the concepts in the case of the system, the second point we need to understand is engineering part. Now the basic question will come, what is engineering? Suppose if somebody asks what is mean by science, you will immediately say that it is understanding nature or natural principles and laws. So observing and understanding the natural principles and laws is coming under science. But after knowing these laws and principles, how you are going to apply them and demonstrate them in different parts is going to come under the engineering. So here, suppose if we say rocket, immediately somebody will say there is a Newton's third law. But we already discussed that Newton's third law is not completely the rocket. Rocket contains different laws and concepts within it. So, but in order to realize the Newton third law, there is a need of some form, there is a need of some structure, and there is a need of some functionality, right? So that is the reason why basic science or basic concepts may be same. For example, the Newton third law will come in rocket. At the same time, Newton third law come in swimming also. But the demonstration of the Newton third law cannot be same. That means if you say only in swimming I find the Newton third law, so any demonstration related to Newton third law must be demonstrated in this fashion only. If you define like that, the rocket should have the hands that will flap like a bird to go or take off. Am I right? That means even though law is same or the concept is same, the demonstration of the concept or the realization of the concepts always depends on the conditions and environment. That's why you have to demonstrate the same law for different conditions and different cases. So here the point you need to understand as an engineer. So if you somebody asks what is mean by engineering, you have to tell this. Yes, I know the fundamental laws, concepts and principles, but as an engineer, I have an extra capability how to manifest or mold this fundamental concepts or principles for different cases and situations. So that is going to be the key quality or key ability of the engineer to claim oneself as engineer. That means you should be able to build things or build suitable forms, structures, functionalities, and behaviors for different cases and conditions. If you have that capability, then you can claim as engineer. And that's why, so fundamentally understanding what is mean by engineering is like this. So engineering is a process of building suitable forms, structures, functionalities, and behaviors depending on the conditions and different cases. So, rocket is the realization of Newton's third law in a particular case. Swimming is also containing Newton's third law, that is different case or different conditions. That's why even though the fundamental law or concept is same, the manifestation of concept into the system having different ways in different conditions. This one must understand, and this one must gain to claim as a engineer. So engineer must have this capability to build system building means you are actually building suitable form to realize a concept, suitable structure to realize a concept, suitable functionality to realize a concept, suitable behavior to realize a concept. So fundamental law is same, and suitability according to the conditions and cases engineer is going to decide. So after deciding that, suppose for example in the case of rocket, in order to realize the Newton third law, what is the important thing we must have or we must achieve is the required thrust. The required thrust we achieve, then only the rocket will follow, or we can demonstrate the Newton third law where there is a action equal and opposite reaction. So that is the reason why the Newton third law, to realize the Newton third law, we must achieve the required thrust. But achieving the required thrust just like that will not happen. So you have to achieve something, or you have to build some structure or a form to achieve that. In that structure, you need to achieve the required force. Force is a parameter. So if you achieve the required force, there will be acceleration in some other direction, right? So there is action, there is a reaction, there is a force involved, there is acceleration involved. Am I right? So that means in order to realize your concept or the law, for example, Newton's third law, you must build a structure. The structure name is engine. The structure name is engine. That engine you have to build. For that, you have to define the structure. So you define the structure with respect to parameters. So what is the height, what is the volume, what is the temperature, what is the capacity, what is the efficiency. These are all different parameters you have to define in that engine, right? The same way you define some form. So form should be defined through some parameters. You define some functionality. In this case, creating thrust is the functionality. So you define the functionality with respect to some parameters like force, acceleration, and these things, right? So that means there is some capability engineer must demonstrate beyond the basic science. That means he must know the basic science. At the same time, he must know how to apply the fundamental laws or concepts in different cases and different conditions, because it is not like that same law I can use in the same way in all conditions. It is different. So one must understand, when you are applying different laws or realizing different laws in different conditions, you have to create accordingly the structure, form, functionality. So the structure, form, functionality must be built by defining some parameters. That may be optical parameters, thermal parameters, geometrical parameters, or any other parameter type. It doesn't matter. So to build form, suitable structure, suitable functionality, to realize a basic concept, you must propose suitable parameters. And these days you may call them as specifications, right? So once you propose the suitable form, structure, functionality with the suitable parameters, then you are actually building a thing that is going to realize your basic concept or manifest your basic concept in that particular case, right? Now, so two capabilities we are seeing here. First, you must know, you must have a strong hold on scientific principles and laws. Second, you must be able to apply them in different conditions in a different manner and suitable manner. Third, you have to propose different forms, structures, and functionalities to realize these scientific principles through proposing the different parameters or suitable parameters. So these are the three capabilities as an engineer you must have. So same way, in order to understand any system, you have to follow the same approach. So any system you take, in that you find a different, you find a form, that means externally how it is appearing. You find a structure, that is it is combination of different parts connected in a particular manner, which we call as connections. Different parts are connected through connections. Then there is a structure. Then functionality, that means it will actually do many, it will fulfill many purposes. Those are called functionalities. So these all things you have to see in a system, but these all things should be understood with respect to different parameters involved in that system, right? So without doing the parametric analysis, if you say I understood the engineering part of this system, that is only a fake reality. That's not correct. If you say I understood the engineering of so and so system, you must have understood its form with respect to some parameters. You must have understood the structure with respect to some parameters. You must have understood the functionality with respect to some parameters. Behaviors we will talk later, right? So that is the capability. So definition, we can clearly say that the ability to build suitable form, structure, functionality, and behavior for different conditions and different cases is called engineering ability or engineering. So this you please remember. So in the same way, if you just to convince people uh, in different cases which India already achieved. So I would like to show some examples. So I generally discuss in the class these example. For example, if you GSLV rocket we achieved. So GSLV rocket is for putting the satellites in the geosynchronous orbit. So for that we need specific conditions. For example, that height should be only 43.5. You cannot keep high or less. And there is a parameter related to fuel. There are parameters related to its engine. There are parameters related to its form. There are parameters how different parts are connected. So this is the system created for a case where it has to have the payload and it has to create the sufficient thrust through fuel burning, and it has to lift off with a particular velocity. Then it has to go to some orbit and leave that particular payload there. So it is created for those conditions. So engineering will change. That means form, structure, functionalities will change. That means different parameters related to form, structure, and functionality will also be changed, right? So that is one case. Same way we can give another example like Covaxin. Covaxin is a vaccine made by India. This is the vaccine for the COVID, right? Having efficacy, we say it is around 73 or 78, some number will be there, right? But is it an engineering system? Yes, it is an engineering system, because vaccine is nothing but it's a chemical. Chemical is nothing but a molecule. Molecule will always have a structure. That structure sometimes, that structure and the molecule decides how it works, nothing but functionality. So this molecule should go inside, stimulate your immune system to create some antibodies. Those antibodies will go and fight the virus, right? So this is also a system which actually exhibiting structure, functions, and behavior. Form may not be there, it's okay, but still you are keeping those molecules in a medium. That medium should not interact with this molecules. That means there is a parameter you need to consider, that the reactivity. At the same time, this molecule has structure, so structural parameter you can define. The molecule will have its own orientation or conformation, that will have set of parameters you need to define, and a molecule will have its own chemical reaction capabilities. So you have to define those things. So what antibodies it is going to create, those functionalities you have to define and achieve. So this way, the, even vaccine is an engineering system, chemical engineering system, where you find same concepts like structure, functionality, and behavior. So where you need to define different parameters, even efficacy is a parameter, right? So define those parameter accordingly. You build the system, then that system is used for some purpose that depending on the functionality, right? Same way, suppose one bridge we recently India built on Chenab River, so highest bridge in the world, that is Chenab Bridge. That if you closely observe, there also very different aerodynamic conditions. It is not like a normal aerodynamic situation. Temperature is very less. Aerodynamic situations are different. Terrain is very hard to move, and the terrain is very difficult to build. So, but they still built this bridge. But the design, if you see, the structure is different, materials used are different, and form is different. That means everything is decided based on those conditions. Am I right? So those conditions will decide what form to be used, what function to be used, what structure to be used, what materials to be used. If you are able to propose the parameters accordingly, then you are an engineer. The same way, you also can know about the Vande Bharat Express, which is an engineless train built by India. At the same time, hydrogen bus, where there is no engine at all. So complete engineering will change, right? So that's the reason why cars with hybrid cars, which will run with ethanol, where you are changing the fuel. So your internal combustion, you can't use the same engine, so you have to use the different engine. So based on these all things, that may be supersonic missile assisted torpedo, which you can use both in aerodynamic medium and hydrodynamic medium. So these are all needs different engineering, different form, different structure, different functionalities based on the conditions in which they need to work. In the first rocket, in the torpedo, there may be Newton third law, but conditions are different. So engineering is also different. Parameters also different. Form, structure, function is also different, right? So this one must understand to claim as a engineer, right? So let me rewind the definition of engineering. So engineering is the process of building suitable form, structure, function, and behavior for different cases and conditions. So this is what engineering. If you have the capability to build either form, structure, or functionality or behavior for a particular case or for a particular condition, then you are a engineer. Okay, thank you.